Today in this session, we will go through effect of mean stress, effect of notch, and also minus rule of damage, linear damage accumulation. With regard to the mean stress effect, as we know, the constant amplitude represented by three different categories. Most of the tests are conducted R is equal to -1 with mean stress is 0. And other cases like repeated and fluctuating load, the material spreads at lower alternating stress than it does in the fully reverse loading. So obviously the R values to take into account the effect of mean, it is required to take into account the effect of R of a certain curve generated for R is equal to -1. The different equations are more proposed based on the effect of mean stress, because if you compare the life of a given mean stress generated R is equal to -1 is the baseline. So in the case of positive mean stress, your life will decrease. For negative mean stress, you'll have increase in life. So the equation that is available to take into account the effect of mean stress are Soderberg, Goodman, Gerber, and Morris, where S is the stress amplitude, Sm is mean stress, SU ultimate tensile strength of material, and SE is the equivalent stress per sigma m equal to 0. Basically, if they are plotted on a stress amplitude in y-axis and mean stress in x-axis, one can represent any equation. For example, Goodman equation, when S mean is 0, your stress amplitude comes to SE, is the endurance limit. But when stress amplitude is 0, it can go to the ultimate stress as per the Goodman's equation. Depending on which model is used, when stress amplitude 0, it can be sigma y based on the Soderberg, or it can be ultimate stress by the Goodman equation, or Morris equation is a flow stress. Basically, what this equation does is it transforms the non-zero mean applied stress to an equivalent stress amplitude having a mean stress of 0, whose damage is same as applied stress. To understand the example, let us have a SN curve of different stress ratio. Suppose we have a stress ratio of 0.1 and we consider around 145 megapascal as a stress. The damage, that is failure, occurs 10 to the power 5. To map it to a equivalent amplitude, you consider same damage of 10 to the power 5 and find out what is the equivalent stress that will give the same damage, which is what to be 245 megapascal of R is equal to -1. Now, considering the effect of notch, it is already known that fatigue failures usually occurs at notches or stress concentration. Almost all machine components and structural members obtain some form of geometrical or microstructural discontinuities. If you consider the structure subjected to stress S, then your stress concentration factor is defined as maximum local stress by applied stress. And it depends on geometry and mode of loading. But in the case of fatigue, there is one more stress concentration factor operates that is known as fatigue stress concentration factor, depending on whether axial or shear. That is defined by KF. As per the definition, it is fatigue strength of smooth spherical at 10 to the power 6 cycle to fatigue strength of smooth notched spherical at 10 to the power 6 cycles. So usually the SN curve, which is obtained for unnotched or smooth curve, will have a decrease in life based on the notched specimen of different stress concentrations. So more the higher the stress concentration factor, the lesser will be the life. Now coming to the minus rule of linear damage accumulation, the fatigue damage was based on the linear damage, and usually it is done in based on the some assumptions, because the damage which occurs to the fatigue loading is neither observable or measurable, unlike in crack length. So usually because of this, most damage summation methods for initial phase are empirical in nature. So in 1924, Palmgren uses linear damage accumulation to define the cyclic life of bearing. So which was basically used for heavy industry, was borrowed by Miner in 1945 to apply to the damage in aircraft fatigue. So it is known as Miner's rule. So if you apply a specific stress amplitude at a given stress ratio, at one cycle there will not be damage, but if it is repeated continuously at certain number of cycles, say NR, where failure will occur into two pieces, then damage is equal to 1. So usually Miner's rule says that the failure of the part will take place when the total fatigue damage value become equal to or greater than 1. So the subscript are defined as number of blocks or number of cycles the structure can experience at different stress level. Thank you.